In this lecture, we'll see about the continuity of the function. We'll see the topic evaluation of function at a given point, definition of continuity, examples and problem related to continuity. Let us see this first example. Here we have to function is given as x square plus 2x plus 1 and we have to find its value at x is equal to 1. So simply put x is equal to 1 in this function and we get the answer as a 4. Now in this case the function is given in two different definitions are given. When x is less than 0 its value is 1 minus x. When x is greater than equal to 0 its value is 1 plus x. So when we evaluate f at minus 2, because minus 2 is less than 0, so we'll use this 1 minus x definition and we'll put x is equal to minus 2 and we get value 3. Now when we evaluate f at 2, because the 2 is greater than 0, so this formula will be used and we'll put x is equal to 2, so we get the value 3. Now let us see the definition of continuity. It's very easy. A function is continuous at a point c if limit x tends to c fx is equal to fc. That is, three things are involved over here. The function fc is defined, that is this is defined. Limit x tends to c exists, that is this limit. It means the left hand limit is equal to right hand limit. And how to evaluate this we'll see in the example. And third, these two values should be equal, that is this value should be equal to the value at c. So the fx is continuous at c if first of all left hand limit should be equal to right hand limit and it should be equal to the value of function at c. These three requirements are there when we say it is continuous. If any one of this is failed, we will say it is not continuous. Let us see this first example. Here fx is given as x minus 2 when x is less than equal to 0. It is given as x plus 1 when x is greater than 0. Now we'll check continuity at x is equal to 0. So first we'll find left hand limit at 0. When we find left hand limit at 0, it means the value of x is less than 0. So in this case, this definition will be used. So we write x tends to 0, x minus 2 and we simply put x is equal to 0. So 0 minus 2, it is minus 2. When we calculate the right hand limit, it means the value of x is greater than 0. So this formula will be used and we'll write x tends to 0, x plus 1. We put x is equal to 0 over here, we get the value 1. Now you can see in this case, this left hand limit is minus 2, right hand limit is 1 and these two values are not equal. So we say limit does not exist and limit does not exist. It means function is not continuous at x is equal to 0. Now let us see one more example of this type. It is defined as fx is 2x when 0 less than x less than 1. Its value is 3 when x is equal to 1. Its value is 4x when 1 is less than x less than 2. Now when we calculate left hand limit at 1. Now when we calculate the limit, left hand limit at 1, it means x is less than 0. And when x is less than 0, this formula will be used. So here we put 2 and the value of x is 1, so we get the value 2. When we calculate right hand limit at 1, it means x is greater than 0. So this formula will be used. So it will be 4 into 1, that is 4. Again you can see the left hand limit is not equal to right hand limit because it is 2 left hand limit, right hand limit is 4. So these two are not equal. So simply we can say it is discontinuous at x is equal to 1. Now in this next example, here fx is given as a 1 minus x when x less than 0. It is given as a 1 plus x when x is greater than equal to 0. We have to check continuity at x is equal to 0. So now calculate left hand limit means x is less than 0. So this formula will be used. Note that we'll put x is equal to 0, we get the value 1. When we calculate right hand limit, when x is greater than 0, so this formula will be used. We'll put x is equal to 0 over here, we get the value 1. So here you can see this left hand limit is equal to right hand limit, and the value of function that is f0, that can be calculated by this formula. Putting x is equal to 0, we get all value as a 1. So these three are equal, so we say function is continuous at x is equal to 0. Now let us see one more example. Here fx is given as a 5x minus 4 when x is less than 1. It is given as a 4x cube minus 3x when 1 is less than x less than 2. And we have to check continuity at x is equal to 1. So first we'll calculate left hand limit. So left hand limit means x is less than 1. So we use the formula 5x minus 4 and we put x is equal to 1. Note that you have to put x is equal to 1, not minus 1. This is just symbol. This is just symbol to show that left hand limit. So putting x is equal to 1, we get value 1. For right hand limit, when this means x is tending towards 1 from right hand side, so the value of x is greater than 1. So this formula will be used, and here we put x is equal to 1, we get the value 1. And the value of f at 1, that can be calculated by this formula. By putting x is equal to 1, we get the value 1. So all three are equal here in this case. You can see the left hand limit is equal to right hand limit is equal to the value of function at 1. So we declare that function is continuous at x is equal to 1. Now these are some problems you can try. Here we have to check the continuity at x is equal to 3. So find left hand limit and right hand limit and the value. Here we have to check the continuity at x is equal to 2. And in this case we have to check the continuity at x is equal to 0 and x is equal to 2. So these are again the exercise. We have to check the continuity at x is equal to 1. Here we have to check the continuity at x is equal to 2. Thank you. You can find this PDF in description in which the link is given for this PDF. Thank you.